All right, so in this example, we need to draw our triangle first. So we have a triangle um, FDE. So again, just sketching a triangle. Doesn't have to be anything crazy. Sketch your triangle and then label the information we're given. So we have FDE, so we have F, D, and E. And again, just noticing this, the sides we're given, we have angle E, which is 74.8. We have side E, which should be opposite of the angle E. So 24 is over here, and side D, which is 22. So there's the setup. There's the information we know. Again, at this point, if you notice, we only have one angle, but the important thing is that we do have an angle and the side opposite that angle. We do know both of those things. So there's our complete ratio. So that means we can solve for one of the other missing pieces. And in this case, it has to be, we have to try to solve for angle D first. So we're going to find the measure of angle D, and we can still use law of sines to do that. So again, I like to put the missing piece, the piece I'm solving for, on top. So this time I'm going to set up my proportion, my equation, as sine of D over 22. And then I'm going to set that equal to, and then this time my angle, right? So the sine of 74.8 has to be on top, and then the 24 on bottom. So there's my equation set up. I have a couple steps here to go yet. So kind of like before, to isolate the sine of angle D, I'm going to multiply both sides by 22. And that gets me sine of D is equal to 22 sine of 74.8 all over 24. So that 22 just kind of gets stuck in the numerator along with the sine of 74.8. But then I have to do one more thing before I can actually solve. So before I can actually solve, I'm going to be taking the inverse sine, because again, I'm solving for an angle. So whenever you're solving for an angle, just like in right triangle trig, when you're solving for that angle, you have to use the inverse sine. So you're actually just going to be doing angle D is equal to the inverse sine of 22 sine of 74.8 all over 24. So it looks kind of weird, but you're going to have the inverse sine, and then you're also going to use the sine function inside, but we can go ahead and get that typed into our calculator now. So start with your inverse sine of, and again, if you're not sure, use extra parentheses. Or if you have a TI-84 plus Silver Edition, if you hit the green alpha key and then the Y equals, so the first button along that top row of the kind of skinny buttons, alpha Y equals, and then that first option number 1, is a fraction template. That's something that you have access to if you have a TI-84 plus and you have the math type features. That makes it easy to show for you to see what you're typing into each part of the fraction. So I still like to close that parenthesis and scroll down to the bottom, type in 24. I like to close this parenthesis as well. And then there you go. You can double check your work, make sure you typed it in correctly, hit enter, and we get 62.20214, and so on, so on, so on. This is an angle, right? So we're finding the measure of angle D. So angle D, again, to one decimal place, the nearest tenth, is 62.2. Now, on your calculator, I'm not going to do anything else quite yet because I know, thinking ahead here, I'm actually going to need to use that value. So whenever I need to use a value that I calculated, I have to use the unrounded value. So that's where it's helpful in your calculator to know what answer goes with the question you're working on. You can go back up and quick select it, that kind of thing. So at this point, I have two angles. I can solve for the third one. And to do that, let's just go ahead and do 180 minus, and notice I'm going to use that previous answer. So if I hit second and then the negative button, that pulls down the previous answer, and then minus 74.8. So that right there is the measure of the third angle. So the measure of angle F is equal to 42.997.8, so on, so on, so on. So the measure of angle F is, to one decimal place, that 9 is going to round the 9 up, which then it rounds the 2 up. So 43.0. That is degrees. I forgot that label down here. Those are degrees. Okay, so they're angles. Those are the degrees. So now at this point, we can solve for the third piece, the third unknown piece, which is the missing side. And that would be over here. Technically, it would be side F. And so I'm going to try to fit that, squeeze that in right here on the side. And at this point, again, we're just setting up another sine equation and thinking about what pieces we need to use. So if I'm solving for side F, I need to use angle F in this calculation. So I have F over sine of, and I'm not going to use 43. I'm going to use the 42.9 ... That's important. Notice in my calculator, I still have it there. I'm going to leave that there for just a second. Finish writing down my equation, and then we're using our complete ratio, which again, side is on top this time, so 24 is on top, over sine of 74.8. So my calculation in my calculator is going to end up being F equals 24 sine of 42.9 ... So that's, again, this decimal is the unrounded answer I'm using, over sine of 74.8. So in my calculator, here's what that looks like. 24 times the sine of, again, that previous line is the previous answer that I want. So 42.99, so on and so on. Close that parenthesis, divided by sine 74.8. And I end up with 16.9606, so on, so on, so on. And to one decimal place, once again, the 9 gets rounded up by the 6, which then is going to round up the first 6. So 17.0. And our units on this are centimeters. There we go. And there are the 3 unknown missing sides, or missing pieces, that we did.